Hey guys, welcome to the channel VIBGYOR of Talent. So in today's video, we'll be starting up with a new chapter named Quadratic Equations. So by looking at the name of the chapter itself, you might be telling that it's from the math subject. Yeah, it's from math subject and this chapter is taken from class 10. Alright, let's get started with this chapter. So in the previous chapter, we have studied different types of polynomials if you guys remember. So one of the type was the quadratic polynomial. Do you guys remember the form of the quadratic polynomial? Oh yeah, the form of quadratic polynomial is ax square plus bx plus c. And then a shouldn't be equal to 0. So the keen ones among you might ask me what is the reason for a not being 0? Why shouldn't a be 0? So if you substitute 0 in place of a, the entire polynomial will turn into a linear polynomial. What is the reason for becoming into a linear polynomial is that when you substitute 0 in place of a, it will get multiplied with x square. So anything multiplied by 0, what will it become? It will become 0. So this entire term will become 0. So what will be left? Only bx plus c will be left in the polynomial. So then it will get changed into a linear polynomial. But for quadratic polynomial, the condition is that the highest degree should be 2. Then only it will be a quadratic polynomial. But if we remove this x square term, if we multiply it with 0, what will happen? The degree 2, that is the x square term, will get destroyed. So what will remain? Only bx will remain. So the bx will contain the degree 1. So it will turn into a linear polynomial from a quadratic polynomial. That's why a shouldn't be 0. So then, when we equate this following polynomial to 0, we get a quadratic equation. So simply, if we add ax square plus bx plus c equal to 0, then this entire thing changes into quadratic equation. If you don't write is equal to 0, it will be a polynomial, and if you keep is equal to 0, then it will change into a quadratic equation. Simple. But in any case, a shouldn't be equal to 0. I've said you the reason to write before. And also in a quadratic equation, we have the values of a, b and c are real numbers. Remember this point too. Now let's look at quick examples of this quadratic equation. First up, we have 2x square plus x minus 300 is equal to 0. So how do you know this is a quadratic equation? Simply compare it with the form ax square plus bx is equal to 0. So as you can see, it's as it is present in that form only. You can even pick out the ABC values. So as the coefficient of x square is 2, the value of a will just be 2. And before x, there is 1 standing. So the value of b will be 1 as the coefficient of x is 1. Remember guys, if there is no number before the coefficient of something is empty, then it is not 0. It will be 1. If it would have been 0, the entire term would get 0 because anything multiplied into 0 is 0. So the value of b will be 1 and the value of c would be minus 300. So this is absolutely a quadratic equation. You can even check this by using a simple trick just like that. And then we have another example which is 4x minus 3x square plus 2. Here also no need to worry at all. This is a quadratic equation itself. So just rearrange the terms that you see here and then you'll get a quadratic equation in this form ax square plus bx plus c. So if you try to rearrange this, then we'll get minus 3x square plus 4x plus 2. Here also we can get the ABC values. So what are they? So the value of a would be minus 3, the value of b would be 4, the value of c would be 2. Simple. And in fact, any equation of the form p of x would be 0. So where p of x is a polynomial of degree 2 is known as a quadratic equation. But when we write it in the terms of p of x in descending order of their degrees, then we get the standard form of the same equation. So what will it become? It will become ax square plus bx plus c is equal to 0, where a is not equal to 0. So this is called the standard form of a quadratic equation. This is really important, remember that. And these quadratic equations arise in several situations in the world around us and in different fields of mathematics. So now let us look at a daily life problem which is really simple to solve. So this is the question that we have here. Let's have a look at this question. So in here, John and Jivanti together have 45 marbles and both of them lost 5 marbles each. And the product of the number of marbles they now have is 124. So we would like to find out how many marbles they had to start with. And we should represent this situation mathematically. So what do they mean by representing the situation mathematically? So it's given to us in the form of words. We should convert it into a form of mathematics in which we can solve and find out each of the values. So how can we do that? We can do that by considering variables instead of the unknown values, and then we can find out. So we should basically represent this in the form of equation. So as this is the quadratic equations chapter, so we'll be able to get a quadratic equation out of this word problem after solving. So we should do that to this question. Alright. So now let's see what all the things that we have been given in this particular question. The first basic information that we have got is that John and Jivanti together have 45 marbles. So here, as you can see, the number of marbles with John plus number of marbles with Jivanti would just add up to 45. So we have written it. The first information that has been given to us was written like this. And then let's consider the number of marbles with John as x, because it's the unknown quantity that we have and we want to know that particular quantity itself. So that's the reason we'll consider the number of marbles present with John as x. And then if you try to also represent the number of marbles present with Jivanti in terms of x, it would be 45 minus x. So you'd be wondering, how did we get this 45 minus x? So there is a short story behind that. I'll tell you now. So what happens is that if we consider the number of marbles present with John as x at first, and then if we consider the number of marbles present with Jivanti as y, so x plus y would be 45. Alright, great. So now what would you do if you want to know the number of marbles present with Jivanti only? So you want to find out the y value, but you don't know the x value yet. So what will you do is to just make this x jump on to the left hand side if it is on right hand side, and to the right hand side if it is on left hand side. So in here we have it on left hand side, so let's just bring it to the right hand side. So what would it become? Y would be nothing but 45 minus x. So now if we write it in the form of 45 minus x rather than making it two variable, so it would be more easier for us to make this problem and solve this problem into an equation. So now we have written it as 45 minus x, as the value of y would be 45 minus x if this x goes to the right hand side and becomes 45 minus x. Alright, cool, we have got this. And then we have been given something else too if you look at the next sentence that we have in the problem. So we have been also given that both of them lost 5 marbles each. So if both of them lost 5 marbles, how many marbles would they now have? So as we have taken x as the number of marbles present with John, so after losing he would have x minus 5. And then the same with Jivanti too. So before she had 45 minus x. So now after losing 5, it would just become 45 minus x minus 5. So we have two numbers here, so let's just simplify it. It would become 40 minus x simply. So that we have wrote the second thing also that has to be given to us from the question. Then if you just look at the next line that we have in the question, we have been given the product of these marbles, the number of marbles present with John and Jivanti. So they gave us that the product of the number of marbles they now have is 124. So what would it become? The number of marbles present with John into the number of marbles present with Jivanti after losing each 5 would be 124. So this would be something useful for us as we have both the left and right hand side. So let's just try to multiply them. So what would become? The product would become x minus 5 into 40 minus x. We are just multiplying the number of marbles present with John and the number of marbles present with Jivanti. So this is basic calculation. Let's try to solve now. So if you try to multiply this, the equation would turn up something like this. So first of all, if you multiply the first bracket with the second bracket, in the first bracket let's take the first term that we have, which is x, and then multiply with this entire second term, both the terms in the second bracket. So what would become x into 40, which is 40x that we wrote there, and x into x would become x square minus, remember that minus, so it would become minus x square. And then we have completed the first term in the first bracket. Let's jump on to the second term in the bracket, first bracket. So it will become minus 5 into 40, which will turn out to be minus 200, and minus 5 into minus x would be plus 5x. Alright? And then if you try to simplify this particular equation, 40x minus x square minus 200 plus 5x, you see something similar. That x term, there are two x terms here. So let's try to add them up, and you can also rearrange this equation in the form of ax square plus bx plus c. This is a standard form of quadratic equation to look more prettier. So we have arranged this as minus x square, and we have also added plus 5 to 40, so it will become minus x square plus 45x minus 200. This is the equation that we have right now. So alright, so this is the left hand side part which I have solved right now. But on the right hand side, if you remember, we also have 124. So minus x square plus 45x minus 200 is equal to 124, as it is just the product of both the marbles present with them. Alright, so if we take this 124 from right hand side to the left hand side, as 124 might be just alone, hanging out, just alone, it can come to its friends and play with it. So we are going to just move this lonely 124 to the left hand side to make sure that it's happy along with its friends. So it would become minus x square plus 45x and minus 324. So how did we get this minus 324? Minus 200 and the plus 124, if it comes to the left hand side, it would become minus 110, 124. So minus 200 minus 124 would turn up to be minus 324. So this is the equation which we got finally after simplifying. So it is minus x square plus 45x minus 324 is equal to 0. So if you look at this, we cannot simplify it more further, but we can do one step to make sure that it looks more prettier. So what can we do? We can just take the minus common from this entire equation and write it as x square minus 45x plus 324. So how did we take it common? If we take minus common, so this entire equation, all the signs present before each term would change. So minus x square has become plus x square, and plus 45x becomes minus 45x, and minus 324 becomes plus 324. Well, then if we take this minus to the right hand side again, it would just become 0. There will be no change, because anything multiplied by 0 would just be 0. So no change is made on the right hand side, but as we have taken minus common on the left hand side, we have got a more prettier and good looking equation, which is x square minus 45x plus 324. So yeah, we are done. That's it we have to do. So therefore, the number of marbles John had satisfies this particular quadratic equation. X square minus 45x plus 324 is equal to 0. So we have successfully completed this question. This question was simple and very easy to do, right? So as we are in a good mood to solve more problems on this, let's go and check out one more interesting problem, and it's too simple. So here we have to check whether this is a quadratic equation or not. So what do we have here? The term that we have here is x plus 2 whole cube, which is equal to 2x into x square minus 1. So once again I am telling we have to check whether it is a quadratic equation or not. So this is very simple question. Let's see how it is to be done. So yeah, the equation that we have got is x plus 2 whole cube is equal to 2x into x square minus 1. So by looking at this, you should quickly remember something very important. So what do you remember by looking at it? We can see that we have an algebraic identity that can be used over here. So it is a plus b whole cube indeed. So we have x plus 2 whole cube here. So we can use the identity a plus b whole cube and substitute the values of x and 2 the right places to further simplify it. So what is the formula of a plus b whole cube? It is a cube plus b cube plus 3a square b and plus 3ab square. So let's just quickly simplify it. So as the value of a is x here and the value of b is 2 here, let's just simplify it in the place of a and b. We are substituting it and then simplifying it. So it will become x cube plus 2 cube plus 3 of x square into 2 plus 3 of x and 2 square into 2 square. So it is equal to 2x cube minus 2x. So we have also simplified the right hand side part. So how did you get 2x cube? It is 2x into x square. We got 2x cube, and 2x into minus 1 is simply minus 2x. So we can further simplify this, as we can write it as x cube is same, and then we wrote 2 cube as 8, and 3 of x square into 2 would become 6x square, and 3 of x into 2 square is 4, 4 into 3 would be 12, so 12x, and the right hand side is still the same, which is 2x cube minus 2x. So let's just bring out these two terms also to the left hand side. So the terms on the right hand side are not so alone, but there are only one friend for each of them. So here there are many friends, so they want to meet with new people and make friendship with them rather than just hang out with one friend. So we'll just move them to other friends. So what will we get? We get x cube minus 2x cube, as I have also rearranged the terms, x cube minus 2x cube plus 6x square plus 12x plus 2x plus 8. So here you see some like terms, so let's just add them up. And even we can subtract some of them. So if we do all these calculations, so x cube minus 2x cube, which is minus x cube that we wrote here, and the 6x square remains the same, and 12x plus 2x would be 14x, and the 8 would be same. So the final thing that we get is minus x cube plus 6x square plus 14x plus 8 is equal to 0, and I promise you that you cannot simplify it more further. So this is the last equation that we have got. What is the next thing to do? We have to just compare it with the standard form of quadratic equation, which is ax square plus bx plus c is equal to 0. So now if you compare, we get all the values of a, b and c. So the coefficient of x square is 6, so a is equal to 6, coefficient of x would be 14, and b is equal to 14, and c would just be 8. So yeah, you might be thinking it's a quadratic equation. But no, we have something else remaining here. What is it? Minus x cube. So as you can see, there is something more left after comparing 2. We have satisfied all this, but actually for a quadratic equation, the highest degree should be 2, as I have said you before. But if you look at this particular equation, minus x cube plus 6x square plus 14x plus 8 is equal to 0. So in here, the highest degree is 3. So we cannot say this is a quadratic equation. This is a cubic polynomial indeed, because it says highest degree as 3. Alright? So this is not a quadratic equation. X plus 2 whole cube is equal to 2x of x square minus 1 cannot be called a quadratic equation. Even this problem was very easy. For solving this problem, we just have to remember the standard form of the quadratic equation, which is ax square plus bx plus c is equal to 0. It is very simple, and remember that a is not equal to 0 always. So yeah, as we have done the two problems, which are very easy, now let's try to look at a new and interesting topic, which is solution of a quadratic equation by the method of factorization. First up, let's consider this equation, for example, as 2x square minus 3x plus 1 is equal to 0. And now, if we replace the x by 1, what do we get? If we just substitute in all places where we find x, we're gonna simply get it as 2 into 1 square, as we have x square minus 3 into 1 plus 1 is equal to 0. So if you try to further simplify it, you'll see that the left hand side will be equal to right hand side. So why is it so? 2 into 1 square is nothing but 2, and minus 3 into 1, 3 into 1 is 1, it will become minus 3. So 2 minus 3 plus 1. So 3 minus 3 is indeed 0. So as you see here, LHS is RHS. Both hands we have 0. So by looking at this, we can say that 1 is the root of this quadratic equation. 2x square minus 3x plus 1 is equal to 0. So we also know something else from this. So this also means that 1 is a 0 of this quadratic polynomial 2x square minus 3x plus 1. In the beginning of the video itself, I have said you the differentiation between a polynomial and an equation. So in general, a real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0 if alpha square plus beta alpha plus c is equal to 0. And we also say that x is equal to alpha as a solution of the quadratic equation, or that alpha satisfies this quadratic equation. So both alpha and x are similar and they are actually equal itself. And we also have to note that the zeros of the quadratic polynomial ax square plus bx plus c and the roots of this quadratic equation ax square plus bx plus c is equal to 0 are the same. The name is just different in both of them. But in quadratic polynomials, we just call them zeros, and whereas in the quadratic equation, we call them roots. But the values of both of them are absolutely equal. Remember that. And also remember one more important thing that we have learned in the before chapters, that for a quadratic polynomial, we can have at most two zeros. So any quadratic equation can have at most two zeros. So what do I mean by at most two zeros? It may have two zeros, the maximum, but it can also have lesser. The maximum level is 2. So to get a better understanding of this topic, solution of a quadratic equation by factorization, let's look at a quick problem. So in here, we have to find the roots of this following quadratic equation by factorization. So the quadratic equation that we have here is root 2x square plus 7x plus 5 root 2. So what we have to find for this quadratic equation, we have to find the roots. Hey, what do you mean by roots? The plant roots? Oh, not really. They're saying about the math roots. Okay, we have to find the math roots of this quadratic equation and not the plant roots. So yeah, as we have been given this quadratic equation, we have to first look at two main important things. First of all, you have to look at what is the coefficient of this x square, and we have to look at the coefficient. They would be really important. So in here, we have the coefficient of x square as root 2 and the constant term that we have here is 5 root 2. So the constant term and the coefficient of x square would be really important for solving this quadratic equation by using factorization method. So then the next step is to multiply these both. So we have to multiply the coefficient of x square, which is root 2, and the constant term that we have, which is 5 root 2. So root 2 into 5 root 2 would just become 10, because 5 into root 2 whole square and the root get cancelled, so 5 into 2 would just become 10. So 10 is that number which we have. So we're gonna catch hold of that number 10. We have to do some research for that 10. So this 10 is a very important number also. So you have to see that if you multiply any two factors of 10, you should get the number 10 itself. So if you multiply any two factors, you should get 10. And if you add up both these numbers, you should get the middle term, which is 7x here. So this method got the name as splitting the middle term because we are just finding and splitting the middle term so that we can take common and find the roots. So in here 10. So what are the basic roots that we remember for 10? It is 1, 2, 5, 10, etc. Oh yeah, wait, I found out something. 2 and 5 are the factors of 10. So what can we do with that? So as I have said you, if you multiply both those numbers, you should get 10, and if you add up that, you should get 7, which is the coefficient of x square, the middle term. Alright, so in here, if I multiply 2 and 5, I get 10. First condition, true. And the second condition, it should add up to 7. So 5 plus 2 is 7. Yeah, we got both the equations satisfied. Both the conditions actually satisfied. So we can use them. So how to write them? So we should write them as root 2x square plus 5x plus 2x plus 5 root 2. So 5 and 2 are the factors that we got for 10, which are satisfying both our conditions. So we have to write it as 5x and 2x. So this entire equation becomes root 2x square plus 5x plus 2x plus 5 root 2. By looking at this, you should remember something else that we can take common from first two terms, and we can take one more thing common from the second two terms. So let's take them common quickly. So first of all, as we have root 2x square and 5x, x is common in both of them. So let's take x common, and inside the bracket we write root 2x plus 5. And in the second two terms, we have 2x plus 5 root 2. In here, 2 can be written as root 2 into root 2, as you guys might be knowing. So I have taken root 2 common. We will take root 2 common, and then inside the bracket, we are going to have root 2x plus 5, and make sure that both the brackets have same things common in order to get the roots properly. So we'll be taking common of these, and then we will be finding out the roots from them. So both the values inside the brackets should be same in order to follow the factorization method. So now, as I've said you, we'll take these terms common. So if we take root 2x plus 5 as common, we are going to get x plus root 2 in another bracket. So first bracket root 2x plus 5 and another bracket x plus root 2. So basically, the roots of this equation root 2x square plus 7x plus 5 root 2 is equal to 0 are the values of x, for which x minus 5 into x plus 2 would be definitely equal to 0. So therefore, root 2x plus 5 is equal to 0 and x plus root 2 is equal to 0, as in the beginning of itself we have had the entire equation is equal to 0. So then if you take this 5 from the left hand side to the right hand side, it will become minus 5, and if we take this root 2 from the left hand side to the right hand side, it will become division, and the first value of x would be minus 5 by root 2, and we'll get another value of x, as we can have at most 2 zeros in quadratic equation, and in here we have 2 zeros, and in the second term that we have got is x plus root 2. So if we just take it to the right hand side, it will become minus root 2. The second value of x is minus root 2. So x can be either minus 5 by root 2 or x would be minus root 2. So yeah, we have finally got the roots of the equation, which are minus 5 by root 2 and minus root 2. So we have successfully completed this problem also very easily. So that is it for today, guys. Make sure to subscribe to the channel and hit the bell icon to get the all latest notifications of this channel and all the videos, and I'll be uploading the next part of the same chapter soon. So make sure to subscribe and hit the bell icon, and thanks a lot for watching, and please follow us on Discord, Twitter and Instagram. All the links will be in the description. Thank you once again. Have a very great day.